Welcome to the deep dive. Our mission, well, it's simple, really. Get you genuinely well-informed, quickly, thoroughly.
Yeah, we know you're not satisfied with just scratching the surface.
Exactly. And neither are we. So today, we're tackling something really interesting and maybe more complex than it first sounds. How do we actually develop scientific thinking?
That's right. It's a great question. And we're looking at a review article from the Educational Psychology Review.
Okay.
The title itself kind of gives it away, Seeking a Comprehensive Theory About the Development of Scientific Thinking. So yeah, that's what we're digging into.
How that ability, that way of thinking actually comes about.
Precisely.
Okay, let's unpack this right away then. The article starts with a statement that it really hit home for me.
Oh, yeah.
It says, our society, the tech, the information overload, it absolutely thrives because of scientific thinking.
That's a strong statement.
It is, isn't it?
Oh.
And it makes you realize just how fundamental this skill is. For anyone, really. Just trying to make sense of things, like you listening now.
Absolutely. And, if we just zoom out for a sec, scientific thinking isn't just like an academic thing for labs.
Right.
It's the engine driving progress, innovation, and maybe most importantly, day to day, it helps us sift through all that noise, all the info coming at us.
Make informed decisions.
Exactly. So understanding how it develops. It's not just interesting, it's incredibly practical.
And here's where it gets really intriguing for me.
Yeah.
Despite how vital it clearly is,
Yeah.
the researchers point out this core problem. We still don't really have a comprehensive theory for how it develops.
Right. It's kind of surprising.
It is, isn't it? You'd think with its importance, we'd have sort of nailed that down by now.
Yeah.
What do you think the big hurdles are? Why is it so tough to get one unified theory?
That's a really good question. I think one major challenge is that scientific thinking isn't just one skill. It's not monolithic.
Okay.
It's more like a tapestry, maybe,
Yeah.
woven from different threads.
Right.
Like how we update our concepts, how we judge information sources, whether we even engage with science stuff. It's the mix, the interplay of all these things.
That makes it hard to model.
Exactly. Makes it really complex to capture in just one single theory.
Which leads us to what these specific researchers are up to. They're not starting completely from scratch, are they?
No, thankfully not. They're definitely building on, a lot of solid work that's already out there in educational psychology.
Right.
The article points to several key areas they're drawing from.
Okay, what's the first one? The one that stood out to me was conceptual change.
Ah, big one.
If you think about a time, when your understanding of something just shifted fundamentally, like, I don't know, how you thought the internet worked versus how you understand it now. That's basically what this field studies, right?
Spot on. Conceptual change research looks at exactly that. How we revise our existing beliefs, our knowledge when we hit new information that maybe contradicts what we thought. And this is so central to scientific thinking because, let's face it, science often means letting go of intuitive ideas that feel right but are actually wrong.
Like the Earth going around the sun, not the other way around.
Exactly. A huge conceptual shift over centuries. And for you listening, understanding this process can actually help you spot your own potential misconceptions when you're learning something new, help you overcome them.
That makes it really practical, yeah. Okay, what else? They also talk about the role of credibility and plausibility, how we evaluate evidence, scientific claims. This feels incredibly relevant right now with just the sheer amount of stuff online. How do we decide what to trust?
Oh, absolutely critical. It's not just about looking at the evidence itself, is it?
Yeah.
When you see a claim, you're also maybe subconsciously assessing the source. How credible is it? And also, how well does this claim fit with everything else you know or believe? Is it plausible?
Right. Does it sound believable?
Exactly. Researchers here are trying to understand the mental shortcuts, the heuristics we use for these judgments, and crucially, how those shortcuts can sometimes, lead us astray.
Accepting misinformation or maybe dismissing something valid?
Precisely. Both ways.
Okay. Then there's science engagement. That sounds pretty broad.
It is broad, yeah.
Like all the ways people interact with science, reading an article, going to a museum, even just chatting about a science news story.
That's exactly it. Science engagement covers attitudes towards science, interest levels, participation in sciencey activities in daily life.
Okay.
And understanding what sparks that engagement and what keeps it going is really vital for fostering a scientifically literate society.
Yeah.
Not just what people know.
It's how they interact with it.
Yes, how they relate to it.
Got it. The article also mentions active learning in STEM education, We hear that phrase a lot.
We do.
The idea that doing science experiments, problem solving, is better than just listening.
Right. And what's key here, connecting it back to our topic, is that active learning isn't just about making class more, well, fun, although that helps.
Yeah.
It's about giving you, the learner, a chance to actually do what scientists do.
Like asking questions.
Asking questions, designing investigations, looking at data, trying to build explanations.
So you're practicing the process.
Exactly. By doing those practices, you get a much deeper grasp of both the concepts and what science itself is actually like, the nature of inquiry.
Okay, makes sense. And the last one they mentioned specifically was the development of empirical thinking.
Yes.
Thinking based on evidence observation. Seems pretty fundamental to the whole idea of science.
Absolutely fundamental. If you're not looking at the data, well,
It's not science.
pretty much. Empirical thinking is that ability to, make systematic observations, collect and interpret data meaningfully, and draw conclusions that are actually supported by that evidence.
And that develops over time. It's not automatic.
Definitely not automatic.
No.
It develops over time with practice. So researchers look at how people learn to reason from evidence, how they get the difference between correlation and causation.
That's a big one.
Huge. And how they learn to value actual data over, say, just anecdotes or gut feelings when judging a claim.
Okay, so they're pulling from all these different but clearly related fields.
Right. Synthesizing.
And the article itself, they present it as an example of theory building in action.
Yeah, I like that part. It's a bit meta.
It is, but it's also really interesting if you're curious about how knowledge actually gets made, right? They're showing us their homework in a way.
Precisely. They're not just giving us the final answer. They're sort of pulling back the curtain, showing the process of trying to weave these different research threads together into something more coherent, more unified.
Yeah, that kind of transparency about the process itself is pretty valuable, I think.
I agree. You can see the complexity involved in developing theories in any field, really.
And as part of that process, they mention looking back at their own earlier work, the previous models' perspectives, and they found something they call structural similarity and progressive transformation. Now, we don't get all the details of those models in this preview.
No, it's just mentioned.
But that core idea, that understanding evolves, that it transforms progressively, that really resonates. It feels like how science itself works.
That's a key insight, definitely. Progressive transformation suggests their own thinking on this topic has changed, has built upon earlier versions, incorporated new stuff.
Right.
And the structural similarity probably points to some core ideas or assumptions that have stayed consistent, kind of like anchors, while the details got refined and more nuanced.
It's a good reminder that even the experts are constantly learning, refining.
Always. Science is a process, not a fixed set of facts.
So all this groundwork, pulling together existing research, reflecting on their own evolving ideas,
Yeah.
it's all heading towards a specific goal.
Yes, the ultimate goal.
Yeah.
A novel theory of how scientific thinking develops.
A new comprehensive theory. And they flag a couple of key factors that this new theory really needs to include. The first one is the beneficial outcomes of a more collaborative scientific community. That really puts the focus on the social side of science.
Exactly. It pushes back against that lone geniuses myth. Science is deeply social.
Collaboration, peer review.
Open sharing of data, debating ideas,
Right.
all absolutely essential for progress. So this factor suggests that how individuals develop scientific thinking is also shaped by the social setting, the community they learn in.
So a more collaborative environment helps everyone's understanding.
That's the idea. It fosters more robust, more reliable scientific thinking for everybody involved.
Okay. And the second factor they stress is increasing scientific literacy through deeper science understanding for all people.
Ah, yes. This ties right back to the listener, doesn't it?
It really does. It connects directly to why you might be listening, wanting to be scientifically literate, wanting that deeper understanding. It sounds like their big aim is to help everyone, not just future scientists, get better at this.
Absolutely. Scientific literacy isn't just knowing facts, like the boiling point of water.
Right.
It's having the skills to think critically about science-related issues, evaluate the evidence you see in the news or online, and make informed choices based on that evidence in all parts of life.
So by building a better theory of how this thinking develops,
They hope to inform better ways to teach it, better educational approaches, and ultimately, contribute to a more scientifically literate population overall.
it's probably good to remind everyone as we sort of wrap up the core points from this article,
Yeah.
what we've discussed is based on a preview of subscription content.
Right. Standard practice for many academic journals.
So if you want to really dive into the nitty-gritty, the specific arguments and models, there's more detail available in the full piece for those who have access or want to get it.
Good point. And the article also gives a little taste of related work, doesn't it? It mentions other chapter titles in a figure.
It does. Figure 1 lists a few others. One is about developing intellectual sophistication in scientific thinking, looking at Perry and Deanna Kuhn's work.
Ah, Perry and Kuhn. Yeah, that suggests connections to broader theories of intellectual development across the lifespan. Interesting stuff.
Another title is Science PI, Modeling Conceptual Understanding in Primary School.
Okay, so looking at the very early stages.
Yeah, showing it's not just about adults or college students. They're looking at the foundations in young kids, too.
Important work. And the last one mentioned.
Broadening the theory of scientific thinking for higher education.
Right, so showing it extends all the way up, continuing to be relevant and evolve even in advanced academic settings. The inquiry continues.
So, okay, let's try and bring this all together. Our deep dive into this research really highlights this ongoing and I think pretty vital effort in educational psychology. They're trying to build that complete picture. How does scientific thinking actually develop?
And it's not happening in a vacuum. It's drawing on decades of work on how we change our minds, conceptual change,
How we judge credibility.
how we engage or don't engage with science.
And how we learn by doing, active learning. All these threads coming together.
And this whole effort, it's just so critical, isn't it? Because fostering a scientifically literate society, well, it benefits everyone.
It empowers people to navigate complex
They
issues.
make informed choices in their own lives, health decisions, civic decisions.
And just contribute to a world that's, let's face it, increasingly shaped by science and tech.
Absolutely.
So maybe here's a final thought for you listening to sort of chew on.
Okay.
As you think about how you approach new information, how you try to understand the world, how does your own process maybe align with these factors the researchers are looking at? Credibility, plausibility, changing your mind.
Yeah. And maybe also consider the social part they highlighted. What role do your interactions with other people, discussions, collaborations, your community play in how you develop your own scientific understanding of things?
That's definitely something worth reflecting on.
I think so.
Well, thanks for joining us for this deep dive.
Yeah. Great discussion.